All right, in section 5.5, we're going to solve equations by graphing. Now here's the weird thing. These equations that you're solving, you've already solved them before. You've done them last year. So this is not new stuff to you. This is review. But we're now going to solve them by graphing. And then we're going to solve absolute value equations, which you've also done by graphing. And then we're going to do real life problems. All right, so solving a linear equations by graphing. How do you do it? Well, you're going to take your equation with your variable on both sides. So, for example, the equation ax plus b equals cx plus d, where a, b, c, and d are just rational numbers. You're going to separate each side of the equation and set it equal to y. So you're going to take the left side and the right side, set them each equal to y, and then you're going to graph each one to see where they intersect. So in example 1, negative x plus 1 equals 2x minus 5. Now once again, you can add x to both sides. 3x minus 5. Add 5, get 6 equals 3x. And get x equals 2. That absolutely will work. But I'm just giving you yet another tool. So I'm going to take the left side and set it equal to y. Y equals negative x plus 1. And the right side, y equals 2x minus 5. And I'm going to graph each one of those. So if I graph it, you're going to get a graph that looks like this. And as you can see, these two lines intersect at the point 2, negative 1. But we don't have a y in this equation, it's only an x. So we only need the x value. So our answer is x equals 2. All right, in example number 2, we're going to solve the absolute value equation. If you remember, we want to write two separate equations here. So we would write x plus 1 equals 2x minus 4, and we would solve that. And let's see, subtract x, add 4, that would give us 5 equals x. We would then write x plus 1 equals negative multiplied by x minus 4. And let's see, that would give us negative 2x plus 4. And that would give us 3x equals 3, x equals 1. Now that still absolutely is an acceptable way to solve it. But let me show you how you graph it. So right here, you will notice that we have, let me highlight it here, we have two equations that we've written. We're going to write them as two separate systems. So I could write y equals x plus 1 and y equals 2x minus 4 as one system. And the other one will be y equals x plus 1 and y equals negative multiplied by x minus 4. So what we do now is take each system and graph each system. So there's system 1. As you can see, we have graphed both systems and the point of intersection is 5, 6. We now graph system 2. And you will notice that that graph intersects at 1, 2. All we need is our x values, because we only have an x in our equation. So x equals 5 and 1 are the two solutions to this equation. Now let's look at our last example, our real life problem. So your family needs to rent a car for a week while on vacation. Company A charges $3.25 per mile plus a flat fee of $125 per week. Company B charges $3 per mile plus a flat fee of $150 per week. After how many miles of travel are the total costs the same? First thing I want you to do, pause the video, write down your equation. Pause the video, write down your equation. That's what you should get. You should be able to look at that and say, that's my equation. $3.25 x plus 125 equals 3x plus 150. Now, pause the video, write both systems, or write both equations. write your system. So what I want you to do now is open Desmos. I want you to graph both of these, open Desmos, and I want you to see where the point of intersection is. I want you to do that. Open Desmos, find the point of intersection. If you did it, what's the point of intersection? What is it? It's 100, 450. But we only want x. So what's the value of x? 100. So when are the companies the same? They are the same after 100 miles.